lesson, we are going to learn the complication in data when we identify outliers. So it can be multidimensional, it can be unimodal, it can be a bimodal dataset. It's very interesting. It's because this kind of complication would really give us enough understanding about what we're going to do when we are faced with different attributes in our data. So we would be able to understand how to deal with our outliers and of course our data in general. So doing our analysis when we do anomaly and fraud detection is that we have first to understand the different attributes in our data. And one of the attributes is time. And time here is very applicable when we do the time series analysis because using time, we would be able to understand the behavior of our object through the passing of time. So it can be hourly, it can be weekly, it can be daily, it can be monthly, or even it can be yearly. So it would depend on what kind of time frame we're going to use for our time series. And time is really very relevant and it adds complication to the dimensions of our data set. With that, we have to understand that in time series, there are three attributes that we have to take note of. The first one is label, the second one is time, and the third one is a value. So what is this one? Each one of them all about. So when we say label, it identifies an object. So for example, we consider the temperature as an object. And in understanding the temperature, we have, of course, the understanding that we have to study time. So, for example, how is today different from yesterday and the other day and the other day and so on and so forth. So that's the object. And of course, time. And here, when we say time, we take note of an absolute time. So, for example, we have 12:03, 12:04, and this is absolute. It's because we don't take note of the millisecond. And the third one is value. So it has something to do with numeric value. So we have, for example, the temperature for a given time is 30 degrees Celsius, and during this time is 30.1 degrees Celsius. And of course, because we are talking here of time, we always have to remember of range. Because within a time frame, like for example, we have from 12:00 to 12:30, this is noon and going to the afternoon, there must be a discrete value within this time frame. And not only this one is discrete, it is also fixed. Okay? Say for example, within this time for a 30-minute period, the temperature is just 21 degrees Celsius. So again, within this time frame, we have a discrete and fixed value of the temperature, which is 21 degrees Celsius. And maybe you would like to ask me, is this an absolute universal rule when we talk about range of a certain time frame? Of course, the answer is no. So for a given study, you can always set your time frame. And within this time frame, you can have a discrete or fixed value. Because the assumption is actually within this time frame, there is also another set of data points. That is why in doing a time series analysis, you have to set your time frame within which you can record a certain value of your data. Of your label. So we are good with these different three attributes, the label, time, and value. And now we have to consider the two problems that would arise when we consider time series analysis when we do the anomaly and fraud detection. So the first one is that one time series and there is only one label. So what does this one mean? So this means that we are considering here only one time series, and for all data points, they only refer to only the same label. Say for example, when we have the object temperature And in that temperature, we only consider humidity. With respect to humidity, we are going to identify now which one shows anomalous behavior. Say, for example, we have this. All right. So as you could see, this line here would mean that there is only one label, and that is humidity. So from this point going to this point, there seems to be a pattern. First, it starts from here, it goes up, then it goes down, it goes up again, it goes down, it goes up, it goes down, and it goes up. Although it goes up in this case, but if we are going to examine the previous behavior or trend of our data, then we would see that this one is really very high. And because this is very different from the others, then we can say that this one really displays anomalous behavior. And the other one is that having multiple time series. So in this case, we actually have a lot of labels. So for example, we don't just actually consider humidity in measuring the temperature, but also we take note of the location of a certain area, and also we take note of the number of population or the population density. And so with that, we are going to understand what would be the temperature for a certain time of the day. So because of this one, now we are going to measure the humidity, the location. We are going to measure the temperature based on the given humidity, based on the given location, and based on the population density of a certain area. So for example, we have come up with this one. And also for the location, we have this. And also for the population, we have this one. So with this case, what we're going to do is that we are now going to study or identify which among the three shows an anomalous behavior. Here in our graph, example graph here, we can say that population here shows different behavior from the two of them. So this understanding of complication in doing anomaly and fraud detection is very much helpful because most often actually we deal with the time series data. And so this understanding of the different attributes and how we deal with the one-time series and multiple time series would really give us the proper understanding on how to do our analysis with respect to certain kind of data. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like machine learning essentials, deep learning mathematics, and a lot more. Here, you can always learn an upskill for free.